So we're going to solve this quadratic by completing the square. And in order to do that, we'll change it into the vertex form. So y equals x squared minus 8x plus 11. Doesn't easily factor, so we can use completing the square to determine critical points, in particular the zeros of the function. So we'll take the first two terms, x squared minus 8x, and complete the square. It would look like taking the b term, splitting it in half, so it'd be -4 squared is 16. So we would take that and we would add that 16. What is that? This is a perfect square. X squared minus 8x plus 16 is a perfect square. What is it? It works out to be this, x minus 4 squared. So let's discuss this 16. A little difficulty. We can't just add 16 willy-nilly. We have to say, why did we get it? First off, where did we get it? We knew the 16 comes from splitting the b in half, -8/2, and then square that. -4 squared is 16. But if we're going to add 16, we also have to subtract 16. And of course, we still have the 11. So now it's still equal. So that is the same equation as the one above. We have just added 16, and now we've subtracted 16. So coming down here, -16 plus 11 is -5, and that is vertex form, where h is 4 and k is -5. So from there, we can find the zeros of the function by setting y equal to 0. And by doing so, we can find the values of x. Where does it hit the x-axis? We have added 5 to both sides, so we get 5 equals x minus 4 squared. But then when we take the square root, notice this blaring plus and minus. That comes from the fact that we have this squared, but then we take the square root. So whatever was inside here could be positive, or it could be negative. So we have to account for that by adding the plus minus, because we took the square root of a square. Square root and the square, they cancel, just have x minus 4 on this side. So we add 4 to both sides, and we get x is equal to 4 plus or minus square root of 5. So we can find the values of x, where the zeros of the function. So x for plus square root of 5 works out to be plus 6.23. And then 4 minus the square root of 5 is 4 minus that, which is plus 1.76. So we can graph some of that. Let's begin graphing and show you all of what we can show in graphing. So we can say here is the axis of symmetry, because the zeros of the functions are this value plus this or minus this would be the axis of symmetry is here. X equals 4. And the vertex is found by plugging in the value of x equals 4 at the axis of symmetry and finding the value of y. So x equals 4 is 4 squared minus 8 times 4 plus 11 works out to be -5. So that is the vertex. And here, the 0, the y-intercept is here at 0, 11. And the easiest way to find that, of course, is here, setting x equal to 0, and we have y equals 11. And then the two x-intercepts we have already found. When x is 1.76, when y is 0, and x is 6.23 when y is 0, two values. And then this is a reflected point off the axis of symmetry. We can go from here across over to this side. So the same distance away at 4, this would also be 11. So I can add the point here. That would be 8, 11.